Okay, so for those of you who wanted more practice with solving trig equations where theta has a coefficient of 1, welcome. So hopefully you worked on these before you're looking at this video. So look at problem number 1. You're like, wait, there's two different trig functions. You're right, which technically means in my brain, we kind of have two different variables. So here's the deal. We're supposed to get the variables on the same side, right? So that means I either have to move the sine of theta onto the left, or pardon me, onto the right, or the cosine of theta onto the left. Either direction I move, or either one that I move, I have to divide, don't I? So now let's think about this. If I divide both sides by cosine of theta, that means I'll have sine over cosine, which is tangent. Liking that. If I decide to divide both sides by sine, that means I have cosine over sine, which is cotangent. Which one do I prefer? I prefer tangent. So to get my variables on the same side, I am going to divide both sides by the cosine of theta. That'll cancel cosine of theta off the right. And on the left, that gives me 5. Sine over cosine is tangent. Okay, I can work with that, right? Now what? Good, divide both sides by 5. You got to get rid of that 5, which means you end up with just the square root of 3, don't you? Okay, directions haven't changed. I'm still working with the entire circle. Remember, tangent involves which variables? Y and x, so I'm talking about y over x, and it's supposed to be positive, which means we are in quadrants. Pause a moment, stop and think. Yeah, quadrant 1, because both x and y are positive, so divide them, you still get positive. And quadrant 3, because both are negative, so negative divided by negative is positive. So these are the two quadrants my solutions lie in. Good. But I have the square root of 3. So, which triangle? 30, 60, 90. Make sure you draw it. You're like, I have it from one of the other problems. That's great. Draw it again. The more you draw it, the more you're going to remember it. Are you with me? The easier it becomes to draw. Okay, so tangent. Opposite over adjacent. Give you a moment, take a look. Is that the 30-degree angle or is that the 60-degree angle? Good, it's the 60 because opposite over adjacent gives me square root of 3. So my reference angle is 60 degrees. But how many radians is that? Pi over 3. Good. Just making certain you keep the degree and the radians together so it's easy for your brain to switch back and forth. Good? Okay, so I need quadrant 1, so that's technically 0 radians, and I'm going this direction into quadrant 1, which is positive by pi over 3, which is why it's pi over 3. Now quadrant 3, I'm going in this direction from the reference angle, but I want to make certain it has the same denominator because I'm dealing with a fraction. So yeah, 3 pi over 3. And yes, good, adding pi over 3. That's how we get 4 pi over 3. Good? Excellent. How are we doing? Is this making sense? Lovely. Okay, what about this one? Yep, I hear you. Add the 4. Oops, might want to put the 16 there. Divide by 16, since we're talking about it. Okay. And then, so like I got to get rid of the square. You're right, you need to get rid of the square. So how do you get rid of the square? Square root. One side, both sides. So remember, the square means you're supposed to have how many answers? Good, 2, which means I end up with the sine of theta equaling a negative 1/2, and I have the sine of theta equaling a positive 1/2. Right. Oh, that's interesting. Sine is which y's. Where are the y's negative? Y's are negative in quadrants 3 and 4, huh? Sign is still y, but in this case it's positive. Yeah, that's quadrants 1 and 2. So it looks like I am getting all 4 quadrants, or my solution is going to be in all 4 quadrants. Okay, let's talk about that reference angle. Okay, 1/2. 30, 60, 30, 60, 90 pops up quite a bit when you're doing, when you're solving trig equations. It's just kind of the way it goes. So still draw it so you know, right? Okay, so reference angle is going to be what, the 30 or the 60 degrees, since I'm talking about the sine. Opposite over hypotenuse. So 30 degrees, opposite over hypotenuse. Pi over 6, good. Okay, see if you've got your 4 angles. I'm going to give you a moment. Okay, so in quadrant 3, let me get rid of this. This is supposed to be 6 pi over 6, and I am adding 7 pi over 6. Quadrant 4, this is 2 pi, but a denominator of 6, so 12 pi over 6. Going this direction, subtracting. Quadrant 1, well, that's the easy one, right? And then quadrant 2, good, subtracting 5 pi over 6. Cool? Does this make sense? All right, I have a couple more coming your way, so stay tuned. Okay, so here are the last 2. Tell me what you did. Let's look at number 3. Yeah, you've got 2 sine squared theta minus sine theta equals 0. Notice, initially your variable is sine theta, isn't it? So, does this look familiar? Good, it looks like a quadratic. So problem number 2 was also a quadratic, wasn't it? We took the square root of both sides. That's one way to solve a quadratic. But what's another way to solve a quadratic besides taking the square root of both sides? Factoring. Very good. So both terms have a sine theta in common. So I am going to factor out that sine theta. What remains? 2 sine theta minus 1. Very good. Excellent. Because when you divide by sine theta, one of them cancels. When you divide by sine theta divided by sine theta is 1. Good. So far, so good? All right. So, remember the old saying, if A times B equals 0, if A times B equals 0, then either A equals 0 or B equals 0. Good? All right. This one's technically solved, isn't it? This one? Okay, let's move the 1 over. Let's divide by 2. Wonderful. So far, so good? Okay. Let's talk about this guy first. The answer is 0, isn't it? Is that number on the 30, 60, 90 triangle? Nope. Is it on the 45, 45, 90 degree triangle? Nope. Is it on the unit circle? Yep. So, quick refresher, right? This is 1, 0, 0, 1, negative 1, 0, and then 0, negative 1, right? 0 degrees, 90 degrees, 180 degrees, 270 degrees, and back again. And in radians, 0, pi over 2, pi, 3 pi over 2, 2 pi. Got it. Okay. So when I have an answer of 0 or just a 1, then I'm on this unit circle. Sorry. You're like, where's the circle? There you go. So sine refers to the y's. Agreed? So I need to find where y is equal to 0 on this circle. Here, at 0 radians. Nope. Yep. It's also 0 at pi, and no. So in this particular case, there's not really a reference angle because I'm literally on the boundary line of the circle. It's not actually in a quadrant, it's on the boundary lines. Good? Okay. Sine of theta is pi at 1 over 2. There's that 30, 60, 90 triangle again, isn't it? All right, draw it, draw it. Hopefully we agree on the drawing. Okay, so sine of theta, yeah. What's your reference angle? Sine is 1 over 2. That's 30 degrees. 1 over 2. That's pi over 6, isn't it? Yes? Okay. Excuse me. Okay. This is positive. This is a y again. So where are my y's positive? Quadrants 1 and 2. So my thetas that I'm looking for are in quadrants 1 and 2. Okay, so based upon all we've been working on already, I'm hoping that you know how to find these two solutions. Quadrant 1, simply pi over 6. Quadrant 2, remember this is pi. You're going in this direction. Write it as 6 pi over 6. Good. 5 pi over 6. Cool? I have 4 solutions. Pi, 0 and pi over 6, and 5 pi over 6. With me? Okay. Sorry, making sure my pens don't roll. All right. So let's look at problem number 4. I have 2 different variables again, don't I? Remember one of the other problems we had to divide both sides by cosine, so we end up with a tangent? Because the only way we're removing either trig function is if we divided. Okay. But in this particular case, those parentheses are kind of in my way. So what do you want to do first? You want to distribute? Okay, we can distribute. I'm good with distributing. So you're going to distribute on the right side. Tell me what you get. Good. 7 cosine theta plus 7. Well done. Okay, so let me catch up to you. So I have sine squared theta equals 7 cosine theta plus 7. Good. Now here's the deal. Because of this extra 7, I can't divide both sides by cosine. Because that means the 7 has to get divided by cosine as well. And to divide by sine squared means both of these divide by sine squared. Neither option is looking very good. But here's what my brain is noticing. My brain is noticing that's sine squared. So it's thinking of Pythagorean trig identity. Do you remember the Pythagorean trig identity that involves sine squared? Good. Sine squared plus cosine squared equals 1. Excellent. Which means, I'm going to put it over here so you can see it. Sine squared plus cosine squared equals 1. To get sine squared by itself, I would do 1 minus cosine squared, right? So couldn't I just make a substitution and say 1 minus cosine squared of theta is equivalent to sine squared theta? And when I do that, don't I end up with the same variable, so to speak, of cosine theta? Good. Well done. This is looking even better. Okay. So now what? Some of you are like, move the 1 with the 7. I gotcha. And then what? Tell me what you're noticing. Yeah, I'm noticing it too. I have a cosine squared. And cosine squared tells me that I have got a quadratic, don't I? just like this was a quadratic. So how did you solve problem 3? Yeah, you factored, didn't you? Okay, so, but before you factored, it was equal to 0, wasn't it? Okay, so is that equal to 0? Nope. So the question is, which side do you want the 0 on? Yeah, I want the 0 over here on the left because I want the squared variable to be positive. So I'm going to move everything from the left to the right. So I'm going to get 0 equals positive cosine squared theta plus 7 cosine theta. And now I'm minusing this 1, which gives me a plus 6, doesn't it? And there is a second degree equation. Now, some of you may be okay with this, and some of you may not be okay with this. You're like, I see it's a quadratic, but the cosine thetas are bugging me. Okay, so remember that substitution technique that you learned? We call it U substitution, only because we use the variable U. So if I use this technique, and by the way, if you're like, oh my gosh, I need a refresher on that, go find one of my other refresher videos on U substitution, quadratic, or equations quadratic in format. So this would be U squared plus 7U plus 6. Okay, that's easy to factor. Oh, and that's supposed to be a 0, pardon me. So U plus 6 times the quantity of U plus 1. So set each equal to 0. Oops. It's too easy to write theta all over the place when you're done with trig. So that means U is equal to a negative 6 or U is equal to a negative 1, right? But remember, since U equaled cosine theta, that means that the cosine of theta is equal to a negative 6 and the cosine of theta is equal to a negative 1. How are we doing so far? Okay, let me back it up. Original problem had 2 variables, one sine, one cosine. I made a substitution using the Pythagorean trig identity. I'm noticing this is a square, so I got everything set equal to 0 so I could see the real quadratic. I didn't like the variable of cosine theta, so I made a substitution. This became very easy to factor and solve. And now, you know what I forgot to write here? Since U equals cosine of theta, I resubstituted and out went the U and in went back in my cosine theta. Cool? Okay, so let's go solve this. I'm going to skip this guy for a second. Negative 1. Is that a triangle or is that a unit circle? Yeah, that's the unit circle, isn't it? So remember, your points on the unit circle look like this. And by the way, it's always good to draw this thing as many times as you need to. Cosine refers to x's, and I need to know which of my x's have a negative 1. Not there. Not there. There, so it's pi. Not there. So in this case, this part of the equation, I have one solution, and theta equals pi. Good? Okay. Now, over here, I need to know where my x's are equal to a negative 6. I don't see that. Do you? And if you remember graphing also, when you look at this, negative 6 is out of range. This bottoms out at negative 1 and tops out at positive 1. This negative 6, that answer is out of range. The -6 is out of range. Therefore, this part has no solution, which means number 4, the only solution is theta equals pi. That's it. One solution. That's it. We didn't get anything from this portion, but we only got one answer from this portion. Cool? Okay. Hopefully this makes sense. Hopefully you have a better grasp on solving trig equations that have theta with a coefficient of 1, right? Always a 1 in front of these guys. You have fun with this stuff, and I'll catch you on the flip side.